We'll continue with a test point here S between -6 and -3. So of course S minus S1 it will have an angle of pi, minus S2 it will have an angle of course of pi, and S minus S3 it will have an angle of 0. So the total angle is equal to 0, of course plus or 2 minus pi. And by that the branch between -6 and -3 does not belong to the root locus. The last part of the real axis is S is smaller than -6, and if we apply the angles it will become minus pi, and minus pi, so it is in the form of 2L plus 1 pi, and of course this branch S is smaller than -6 will belong to the root locus. So now let's highlight here the parts of the real axis where I have my root locus. So it is right here where S is smaller than -6, and it is for S between -3 and 0. The next step is to determine the asymptotes of our root locus. So this is HG, or H prime G prime, which is 10A over S times S2 plus 9S plus 18. So if we can look, we will have n minus m, so it means 3 asymptotes. The degree of the numerator is 0, the degree of the denominator is 3. And let's calculate PA. So here PA is equal to the summation of the zeros minus the summation of the poles over 3, which is 0 because we don't have any 0, minus the poles, and we will get a value of 3. So here in this case, the poles, so since we are taking PA is equal to the summation of zeros minus the summation of poles, so the 3 asymptotes will pass by minus PA. So the point minus 3 it means. So let's look at the angle that S plus PA will be doing. So it is equal to 2L plus 1 pi over n minus m, 2L plus 1 pi over 3. And I will take here 3 values of L. So the most easy ones is to take -1, 0, and 1. And I will get these 3 angles, minus pi over 3, pi, and pi over 3. So let's repeat that minus PA, which is equal to -3, it should always be a real number. So if it's not a real number, it means that there is something wrong in our calculation. So let's put the 3 asymptotes. So this is minus PA, or -3 here. So this is the first asymptote with an angle of pi over 3. This is the second asymptote with an angle of minus pi over 3. And this is the third asymptote with an angle of pi. So we already know that one part of the root locus is for S is smaller than -6, so which will be aligned to this third asymptote here with an angle of pi. Now let's determine the breakaway point. So if you look here at our root locus, so we can see that we have one pole which is here, another pole which is here, and a third one which is here. So whenever A will increase, this pole right here will go through minus infinity. However, these two poles, the -3 and the 0, they will be moving in this branch. And for a certain value here of A, they will become one point, and then they will break away into the complex plane. So I don't know for the moment what will be this point, but let's calculate it. So of course you know the way, so we'll put A is a function of S, so we'll get this from the characteristic equation, and then we'll derive A per respect to S, and this is the derivative 1 minus 1 over 10 times 3S2 plus 18S plus 18. And we'll pose 3S2 plus 18S plus 18 is equal to 0. And solving this equation, we will get two values of S. So S1 is equal to minus 4.73 and S2 minus 1.26. So we already know that if you go back to the root locus on the real axis, so minus 4 point something does not belong to the root locus. It's right here. So the value will be here between -3 and 0. So this is why this value minus 1.26, it is our breakaway point. And please remember that the breakaway point should be on the real axis. If the breakaway point is not on the real axis, it means that we have something wrong in our calculation. And this breakaway point S2 minus 1.26 will correspond to A is equal to 0.63. So this is our breakaway point minus 1.86 and A is equal to 1.26.